Hello, dear colleagues. I will present to you interim results of our learning journey on gender gap in STEM. Our learning question was about if we start from a situation like this, it means predominance of girls, why the situation turns into predominance of boys. First of all, we identified, yes, that gender gap in STEM still really exists because only 2.5 times less girls go to STEM specialties in college, and 2 times less girls go to STEM specializations in universities. And this review was conducted by our accelerator lab, inspired by Bhutan and Azerbaijan. Then we identified that the problem exists at the age of 13 to 15, and that's why we created a certain map of factors that influence on girls' decision to go to STEM or not to do this. First hypothesis is that access to STEM infrastructure and urban-rural areas difference leads to this. Second hypothesis was that gender disbalance and disparity in learning groups and parents' influence leads to this. And third is that gender stereotypes and parents' influence leads to this. And we started to explore it one by one. As the first solution we explored is mobile STEM class. It's when equipment is transported from Minsk to Minsk district, rural schools. What we have identified that access to STEM infrastructure isn't a bottleneck for girls, because the access to STEM infrastructure is granted to children that are good in physics and math, but more girls finds physics and math boring, not interesting, not emotional, not creative, and hence no interest to STEM extracurriculum classes, even if infrastructure is accessible in rural schools. Second thing that we identified that yes, gender disbalance in STEM is of thematical and expectational origin. There are certain classes like biology, sociology, chemistry that are also related to STEM, and access to STEM should be granted for girls that not only good in mathematics, physics, and math, but also that are good in biology, sociology, and chemistry. That helped us to broaden the identification of girls from where we take them to STEM specialties. Second result that we reached that yes, parents' influence is a smoothing amplifying factor. 74% of Belarusian parents would like to see their children as a STEM specialists, but girls are also very significant. 51% of parents of girls also would like to see girls in this area. So it means that the difference is not so big. When we mix together the perception of girls, how they perceive the barriers, and perception of parents, we see that some things parents smooth out, some things parents at the contrary amplify. For example, in terms of gender stereotypes, girls perceive, only 11% of girls perceive physics and math as not for girls education, but 24% of their parents perceive that. Then we took another solution, Balatech from Kyrgyzstan, and tried to pitch to parents this 50-50 boys-girls solution. And we've got absolutely no results, absolutely zero interest from parents and girls to go and to participate in this international Olympiad. That's why we identified that we need to be focused only on girls-only solutions. Interventions that we developed, there are 10 types of interventions. We tried to check them one by one. In terms of announcement, there are short-term announcements and long-term announcements on competition, Olympiads, performance, etc. There are detection methods of in-class rankings, tests for predispositions, career maps. There are long-term blogging and communication about the experience of other girls in STEM and experience of adult women in STEM. Joint projects of children and parents, team projects 50 to 50 girls and boys, excursions, and intervention targeting teachers and programs for girls only. We started to test announcements. We took a picture with predominance of girls, created a leaflet on the basis of it, and tried to play with wording. And these are the catchy words that attract both girls and boys most: future development, sport, health, perspective, logic. And in addition, we see that several of them are catchy words that attract girls more than boys: development, future, perspective, and logic. That's why we recommend to use it in your materials also. In a nutshell, what we have identified additionally, for example, that girls-only solutions should be, for example, used like competition motivates girls only if they compete with other girls, not in a mixed environment. We also see that in terms of blogging, girls less oriented on success stories that we usually do. More, they are interested in this age to talk about more barriers and its overcoming as soon as the age 13, 15 for teenagers is a quite difficult age of growing. In terms of joint projects, we see that girls' parents' joint homework and projects and games can increase interest in STEM and development of logic and analytical thinking, and expand understanding of parents about what is STEM, that biologic and chemistry is also a part of STEM education. What we're going to do next, we would like to open a world-class girls-only program for girls from Chernobyl recovering districts in one of our technoparks, and we applied for Digital X program with this. We have 21 districts still suffering from Chernobyl nuclear disaster, have radioactivity. We have Gomel, yellow marked region. We have a new technopark in it. We have premises, and we would like to organize study tours from all of these districts to this technopark for girls, and to open them opportunities to world-class education with Technovation Girls proven solution. That will be the end of our learning journey on STEM and girls in STEM. Thank you.